Everything's distorted. At first, when they go to grab something with the glasses on, right, they'll go like that and miss it. But what happens is, over a short period of time, the person adjusts his movements so that he can get the object. And then pretty soon, with the glasses on, goes right to the object and get it. Perceptual come on. Perceptual, that's called perceptual adaptation. And that's what our room is not doing now. Everybody stand up and jumping jacks. So perceptual adaptation, make sure you know to come on here. This is ridiculous. How much movement do other teachers do? I don't know. I know I was sitting.
You have to push the button.
Oh, there we go. Is that always true? You always have to push the button? Oh, so moving around doesn't... Oh, now, what goes on after sensory system, after all that distortion takes place? That's when Helmholtz says we're talking about perception. So sensation, perception, not the same thing. Sensation has to do with the sensory organ and all the distortions that come with the information we pick up and that our body does to the information. Perception is where it comes together. Now, he couldn't say too much about this. He didn't have the equipment we have today. He couldn't see what's going on. Today, we can see that we have pictures of if somebody's looking at a screen. You can literally see the flash in their eyes, goes to the back of the head, and then moves through the rest of the brain. And it happens in a split second, even quicker than that. And you see a whole, whatever you're looking at. Something's going on in the brain. The best that Helmholtz could do at that time was to say that what has to happen is that the brain takes the information it's given through the sensory system and it makes what's known as an unconscious inference. You fill in, the brain fills in the details. It's one of the first uses of the word unconscious, which you know is going to come a little bit later when somebody else starts talking about it. Here, he's just simply saying, taking bits and pieces of information and then kind of put it together. Actually, Helmholtz really felt that perception is a lot like logic. You know when logic from philosophy class, where they give you a sentence, a second sentence, put the two together, and you get the third. All men are mortal. Socrates is a man. Therefore, Socrates is mortal, right? You get that conclusion because of the first two sentences. You'll see, Fancher talks a little bit about that, where the eye is just getting enough information and then putting together whatever the image is. So you see the two straight lines, the diagonal lines, you put them together. You happen to notice, right, when you're looking, that this line shoots out over here, it doesn't shoot out over there. Right, I should have probably made this a little bit longer so it shoots out there too. That really makes you see the one line look longer than the other, because the two bits of information together are giving you those cues. People walk through, regularly say the top line's longer than the bottom. That's not true, but that's what you're perceiving because of the sensory information that's there. It's another famous illusion. Two even lines. And again, you wouldn't see me draw this. Close your eyes for me. Right. And you put these, this is called a Mueller-Lyer illusion. And again, you dance people through and you have them make judgments. You show a lot. Today you can do this on a computer. You show about 20 of them. And some of the lines are the same, some of the lines are different, and you have to make a judgment. And usually students will say the bottom line is shorter than the top line. Even if you color the arrows differently, sometimes you do that, they still see it as shorter. Because you're getting stimulation that's suggesting a conclusion that happens not to be true, but it's using all the information that the eye is picking up. So perception, not the same as sensation. Sensation gives you bits and pieces of information. And perception is a result of unconscious inference, where you're going to put the pieces together to form the images that, well, Kant would say, are dictated by the categories of understanding. Now Helmholtz actually disagreed with Kant because he thought the categories were not something that we're born with, but that, in fact, we acquire them over time. And one of the examples that he used when he talked about this was the perception of space. Kant would say, space is built into you, it's built into the system. Helmholtz says, you got to move around, trip and fall a little bit, and learn what's there, and then you'll be able to make the inferences of space. So they actually differed on that point, where out says, what you make the inference to is something that you're given already. Helmholtz says you acquire it over time. Now it's true with some spatial situations, you do have to practice to kind of get a feel for what's there. Sometimes if you show some of these illusions to people, they don't, or to children, or people that are not used to drawings, let's say, in some far-off culture, they don't always fall for the illusion because they're looking more cleanly at the lines and can separate the background. But actually today, and in the back of the chapter, they talk about somebody who did kind of put this debate to rest. Is space born in or is space acquired? Of course, they never quite put it to rest, but they got close to it. Yes, hold on a second. I'm trying to think of a person's name. Gibson and Walker did a study, I'll get to you right after this, where they kind of tested this out. They got kids between 4 and 6 months old. They put them on a table, and the table was made up of a checkerboard on one side, and on the other side it was made of plexiglass. And the floor had the same checkerboard that the tabletop had. So if you're looking at this table, all you see is a checkerboard. The difference between this half and that half is the checkerboard's on top here, and then from this half, the checkerboard's on the floor. They got these little babies, put their mommies over here, took the babies over here, and said, go to mama. And the question is, when they get halfway to the table, do they just shoot across to mommy and ignore the difference in depth, which would indicate that they don't know about it yet and have to learn it? Or would they stop and hesitate, realizing, like, I love mommy, but I'm not going to go jump over a cliff to do it? The answer to the question, what they found was that the infants really wanted to go to mommy. They scooted across the first half, but almost all of them stopped. And now again, critics said, well, they're 3 and 4 months old, so maybe they had some practice. But I think that's kind of stretching it, because how much practice could you have in the first couple months of life? And they really weren't crawling that long. So again, it's not a clean answer, but it does seem that there is some understanding of space that's born in, as Kant said. There are probably other areas where Helmholtz was right, where we do have to have some practice in estimating and gauging size.
You said that
yes.
was Gilbert what? Gilbert?
Gibson and Walker.
How does Helmholtz's view of perception differ from how Descartes seen it?
Well, how he sees it, that's a good little pun. Well, the difference would be in what happens to the image on the eye. Descartes didn't know about the retina, didn't know about the structures of the brain. He actually thought, he kind of knew from the geometry of light, if you consider light is bouncing off of you and it comes into my eye, it's going to cross, and when it hits the back, you're going to appear upside down. So he knew that. And he also knew that the light is coming into 2 eyes, so that when I see you, somehow I've got to put those 2 images together from my eye. Now he speculated that it was the pineal gland, because that was the big thing for him, that was what integrated the 2. He didn't really know, in a way, I guess. Are we windy, by the way? He didn't really play into the brain and didn't really, in a way, he didn't really separate sensation and perception. He was kind of saying, well, it happens together. The sensory system gives us this kind of 2 images upside down, and then we have to put it together. We'll let the soul do that right at the pineal gland. So it's a much cruder.
Helmholtz has a more scientific way of looking.
Oh yeah, Helmholtz is a scientist all the way through, and he wants to explain this mechanically. There's no little god in the pineal gland flipping around the image. He's kind of saying, but again, he kind of uses unconscious inference as a bit of a mysterious term, because we don't really know what it is yet. But he does know it's a higher psychological process that has to go on somewhere in the brain. He just doesn't have that part figured out yet. So he's moved us along a more mechanistic explanation of perception. Okay? So sensation, perception. Oh, anybody else? Okay. Sensation, perception. Know about the structure of the eye, the retina, blind spot in particular. Know about the nature of light, basically Newton's little experiment, and that light contains a lot of information that's held together. Also know, by the way, there's a section in there, you don't have to read it closely, but one of the other things that Helmholtz did was talk about how we see color. And what he did there is